Hi everyone, welcome back to our YouTube channel InfinityGreedy. In our previous video, we have started discussing about quicksort, and we were discussing that quicksort is based on three fundamental principles, that is pivot element, second is partition, and third is recursive call. Now we have already discussed that pivot can be first element, last element, random element, can be a median also. And I was discussing that partition. What is partition? Partition is nothing but if we place a pivot element in such a way that it parts the given. For example, this is a problem and you consider, let's say, first element is pivot. So we place pivot to its right position in a sorted array such that it divides the problem into two sub-arrays such that all elements of this sub-array which are coming to the left of it are less than this pivot, and all the elements in this subarray will be greater than this. This is nothing but called as partition. Now to do this partition, there are very common approaches. So we'll discuss those approaches here. The very first approach is called as Naïve partition. Naïve partition. So what happens in this Naïve partition? Let's see. So this Naïve partition, what we do here, we create a copy of the array. We create a copy of array. For example, this is a real array. Okay, this is a real array. Okay, let me give some numbers to it: 13, 14, 5, 7, 0, 1. Just I'm giving a random numbers, right? So we create a copy of array. So I've created a one more temporary array. Now what we do next? First, put all smaller elements and then all greater. So for example, if you're considering one as pivot or first element as pivot or middle element is pivot, then you need to choose. Let me check first element as my pivot. So first put all smaller element, then all greater elements. That is, so first you need to put all, you need to iterate through this array. So once you iterate through this array, you know what all elements are greater than 3, what are less than 3. So first you put all the elements which are smaller than 3, that is 0 and 1. Then you put pivot and then you put all the elements which are greater than this. That is 14, 5, 7. And then you copy this back to this temporary array back to the original array. That is, finally, we copy the temporary array back to original array. So what is the array looks like? Original array will look like 0, 1, 3, 14, 5, 7. So 3 was your pivot. So if you see, all the elements left to it are less than this and all the elements right to the are greater than this. So hence the partition is done. So if you see, it requires extra space, right? What is the space needed? That is O of n. So it needs O of n extra space. That is for the temporary array. And what is the time complexity? You need to iterate, right? You need to just iterate once, that is O of n, time complexity. The space and time complexity, right? So this is what Naïve partition is all about. So I'm not going to use Naïve partitions for my quicksort, right? Because I don't want to take extra space of O of n and then create a temporary array and then copy paste for, because the reason is this is first pass. Then again I have to take another element as pivot, and then again I have to create one more temporary array, and then again I have to copy back. So for me it's a hectic process. Now what is the second common algorithm for partition? That is called as Lomuto's partition. Now this algorithm is again based on the index, so we'll not use exactly this, we'll use its part. So here what we do, I'll just write it. We keep track of index of smaller elements. So what we do, for example, I initialize I as high or low, that is dependent on me. Okay, what is high and low? For example, you have 15, 7, 16, 3, 2, 18. So I may consider this as my high or consider this as my low, or I can consider this as my low and this consider this as my high. Indexes. Remember that we are talking about indexes. So we keep track of index of smaller elements and keep swapping it. And we keep swapping it. Okay. Let me just remove all this. Then what we do? We basically, that's it. We keep swapping. We take the smaller elements index and we keep swapping. So it is simple to use, but not common. Simple to use, but it's not common, right? Time complexity will be O of n because we are taking the smaller element and comparing with other, because it's a comparison based. We will compare it and we'll swap, right? This is not commonly used. But what is commonly used is this, Hoare's partition. So what happens in Hoare's partition? In Hoare's partition, basically what we do, we traverse array from both ends, and keep the track of indexes, keep the track of indexes, swap greater element on left with smaller on right while array is not partition. So this is the algorithm, or this is the way of partition I'm going to use in my quick sort. So don't worry if you don't understand this Lomuto's example, name, partition, or horses. This is the what we are going to use. So ultimately you will understand this. So just wait for an example in our next video where we are going to trace and going to write all these steps for the quick sort, right? So what we do basically here, I'll just explain the meaning. For example, let's say 15, 7, 12, 3, 19, 21. So what we do, we play in the indexes. We consider this as low, we consider this as high, and we initialize this as I, we initialize this as J. Now we'll slide from both the sides. We'll increment I also and we'll decrement J, right? And whatever elements, for example, if I'm get 15 is there, right? If I get elements greater than 15, I will put it into this position, and if from here if I'm getting any element less than 15, I will push it back to this position, right? This is what Horse's partition says about, right? So if you don't understand it, that's okay. Like these things are not in practical, but I just wanted to tell you the three names and how they works in general. But it will be more clear when we talk about an example in our next video. So if you like this video, please do like, share and subscribe. Thank you.